Okay, let's give you guys some practice now. So we've seen in the previous video that if you want to sum up all the terms of this series from the first term all the way to infinity, then we can simply use this formula, provided r is less than 1. Okay, so sum up this series from the first term all the way to infinity. So press pause and have a go. Okay, so the first task is to rewrite this series in this form here. Once it's in this form, then you can simply put the a into the formula here, put the r into here, and then you've got yourself the whole series. Okay, so the first task is to rewrite this series in this form. If you get a calculator and get 81 divided by 27, it will give you 3. So it seems as if it's being multiplied by 3. From 27 times 3, it gives you this. Get a calculator. 27 divided by 9. It seems as if it seems as if 9 is being multiplied by 3. So if you think about it, it will be of this form here. It will be of this form, n minus 1. So because each time it's being multiplied by 3, so when you put in this summation form, n equals 1 and then infinity here. So the first term is you putting the 1 into the n here. So that's to the power of 0. Anything to the power of 0 will be 1. So but then our first term, n equals 1. Well, this whole thing here will give us 1. But then our first term is a ninth. So it seems as if a is a ninth. It seems as if a is a ninth. If n for the second term, n would be 2. N would be 2. So put it into here. So that would be a third to the power of 1, and then times this. So it's really 9 times 3 for this 27, if that makes sense. Well, think about it. Rewrite this thing here in this summation form will give you this. So hang on. So rewrite it. This whole series here can be rewritten as this. So this is your a here. So this is your a here, and your r, and this is your common ratio here. And then now we can just simply put it into here, and then simply put this into the r here. That will then give us this. That will then give us this, and then blah blah blah. So the limit is 1 over 6. So if you sum up this series, if you were to continue all the way to infinity and sum up all the terms, then the whole series will come to 1 over 6. Okay. So next one. So yeah, so sum up this series from the first term all the way to infinity. Remember, you've got an alternating sign here, minus, plus, and so on. So press pause and sum up the whole series. So press pause and have a go. Okay, if you get a calculator and get 125 divided by this, it seems as if it's being multiplied by 5. Here, it seems as if it's being multiplied by 5. So and then at the top, it seems to be constant. So it may be of something of this form here. It's being multiplied by 5 each time. So maybe set it up like this: summation, the first term being 1 all the way to infinity. So when n equals 1, if you put 1 into here, it will n take away 1 if you put 1 into here, it will be 0. So this whole thing here will be 1. But then to get our first term is 2. So this should be our a here. This should be our a. So and then this for the second term, when n equals 2, put it into here. It will be that this thing here will be 1. Well, think about it. Rewrite this in this summation form. Well, if you rewrite this whole sequence in summation form, it will give you this. It will give you this. It will give you this. And don't forget to generate our to generate our minus, plus, minus, then stick a negative in our common ratio. Okay, so yeah, so rewrite this as this, and then once it's in this form, this is our A here, this is our this here is our R here. So now we can simply put this into here. So that's this thing here, and then our common ratio is this. Put it into here, a negative and a negative will turn into a positive. So so that will then take us to here, and then it's blah blah blah. The whole series will add up to 5/3. Okay.